Hello, we are continuing in Unit 6, the integral. Today is Lesson 10, integration by parts. I know it feels like we've been going through these integrals at warp speed, and we have. We've been going through them very, very quickly. A couple words of advice for you. One, make sure that golden ticket is updated, both sides, all the derivatives, all the integrals. If you've come across a few integrals that weren't on that list, that cosine squared and that sine squared, add them on. You want all of those in one place where you can quickly reference them. Now, eventually, for the AP exam, they'll have to be memorized, but right now, you want them easily accessible. What I have for you today is kind of the equivalent of the product rule for integration, but it's not actually a product rule, but it does come from the product rule. So we will integrate functions using integration by parts. So if we want to solve integrals of the form f of x times g of x dx, and by the way, you don't have to memorize this process. I just want you to know where that formula comes from. I'm going to rewrite this as the derivative with the product rule. So fg is fg prime, gf prime. If we change that notation, we use product and quotient rules, we use f and g. When we use integration by parts, they use u and v. Not sure why they do that switch. In fact, some product and quotient rules, they do also use u and v depending on the resource. So if I switch from f and g to u and v, it looks something like this. Now, if I just look at the differentials, meaning kind of forget about that dx piece, it looks like this version. Now, if I have the derivatives of all those things and I integrate, so I integrate d uv, integral of u dv, and the integral of v du, well, in this first piece, the integral and the derivative cancel out, and so I'm left with uv. The second two pieces stay the same. Now, if my job is to solve for the integral of two things being multiplied, all I did was subtract this v piece to the left. And what I'm left with is the formula for integration by parts. And yes, you do have to have this memorized. So it's like super u substitution. We have the integral of u dv is equal to uv minus the integral of v du. Well, what's u, what's dv, what's going on? We have a list, and we're going to go with Liate. I don't know exactly how to pronounce it. Liate, whatever you want to call it. But L is for logarithmic functions. I is for inverse trig. A is for algebraic functions, meaning like your polynomials, x squared, things like that. T is for regular trig, and E is for your exponentials. Great, we have this list. The ones on the left are the U, further to the right is the DV, and it's a sliding scale. So I can't say that I is always, always, always U, but you want to compare the two pieces that you have. So what do I mean by that? Well, if I look at example 1, which is x cosine of x, my x term is algebraic. My cosine of x term is trig. So that means if I'm deciding things, I've got u and dv. The one further to the left on my list, in this case algebraic, is my a, which is my u term. And dv is further to the right, so that's my trig, which in this case is cosine of x. Now, I wrote these offset on purpose. From the u piece, we need to come up with the derivative of u. The derivative of x is 1 dx. And then from the dv piece, we need to come up with the integral. So what's the antiderivative of cosine? It's sine. Now, we have to use this formula that's up here. The integral of u dv is equal to uv minus the integral of v du. And now you substitute all those pieces. So in for u goes x. Nope, let me back up. Started to substitute on the left-hand side, I just want the right. In for u goes x, in for v goes the sine of x. In for v goes the sine of x. And du is 1 dx. So now we have to integrate this piece. What is the integral of sine? Cosine. And this is an indefinite integral, so what goes on the end? Plus c. That is integration by parts. There are a lot of pieces going on for sure. All right, so let's look at the next one, example 2. Let me switch colors here so they don't get mixed up. ln of x dx. So the first thing you always want to ask yourself is, okay, is this somewhere on the golden ticket? Is natural log the answer to a derivative problem? The answer is no, it's not. I can find the derivative from natural log, but it's not the answer to the derivative. So we're going to use integration by parts, but we kind of have to force it. This is the integral from 1 to 3, natural log of x dx. But I can remember that there's a 1 in the front, right? Anytime we're dealing with algebra, it's being multiplied by this 1. So if I'm talking about LIATE, my 1 is an algebraic piece. My natural log of x is a logarithm. So L is further to the left, that's the U. A is further to the right, that's the dV. So we need U is equal to natural log of x, and dV is equal to 1 dx. The derivative of natural log is 1 over x, and the integral of dV, or 1 dx, the integral of 1 dx is x. Now, it's really, really important that you label your work and that you're nice and neat and tidy about what you're doing. Now, for the formula, the integral of udv, is uv, sorry, extra steps today, minus the integral of v du. So in for the u goes natural log of x, in for the v goes the x, minus the integral of x, and du, check this out, is 1 over x dx. Before I do any calculus, I want to simplify this. So this is x natural log of x minus, well, x times 1 over x is just 1 dx. So I've got x natural log of x minus the integral of 1 is just x plus c. Now, this has boundaries on it. This would be a case with the u substitution that I wouldn't necessarily change the boundaries like we did in the last section, in section 6.8. I would actually leave them as they are and then turn everything back to an x and use this. So I would go with x natural log of x minus x. Remember, I don't need the plus c with the boundaries. My boundaries were 1 and 3. So this becomes 3 natural log of 3 minus 3 minus 1 natural log of 1 minus 1. Natural log of 1 is 0. So I've got 3 natural log of 3. And this is a negative 3. This is now a positive 1, so minus 2. And that's my answer. I was talking to a student earlier today, and they said, well, couldn't we take a problem like this and just put it in Math 9? Well, the answer is yes, you can check your work that way, but on the AP exam, you will not have access to your calculator. So I know we've been a little bit loosey-goosey with that this year, in that you've had access to your calculator for the entire test. Well, that's not going to be the case. So make sure that you can do these without your calculator as well. Sometimes we have to complete integration by parts more than once in order to solve the problem. So that's what's going to go on here. So sometimes we have to complete integration by parts more than once to solve the problem. Now, if you find yourself doing it 4 or 5 or 6 times, stop. You've gone too far. 2 or 3 is in the realm of possibility. So let's talk about this one. I have the integral of e to the x cosine of x dx. My e would definitely be an exponential piece, and the cosine is definitely a trig piece. So if I remember my list, LIATE, I've got exponential and I've got trig. They're both pretty far to the right. But remember, anything further to the left is the u. Anything further to the right is the dv. So in this case, my u is cosine, and my dv is e to the x. So for the derivative of u, the derivative of cosine is negative sine dx. The integral of e to the x is e to the x dx. Can you see why you want that yellow paper? I call it yellow, whatever you printed it out on your golden ticket. You want all of these nearby. If you don't have them memorized yet, especially, you want them all nearby. So the formula is the integral of u dv is uv minus the integral of v du. Do you have to have this memorized? Yeah, eventually you do. So well, let's do the u. Cosine of x dx, cosine of x e to the x dx. There we go. I'm just in the opposite order of what it was originally. Is equal to u, which is cosine of x, and v is e to the x. And I wrote a dx on this one, and it doesn't actually belong there. Minus v, which is e to the x, and du is negative sine of x dx. Okay, so normally I'd go through and just integrate the second piece here the best that I could, but I still have two things being multiplied. So this is still integration by parts. I'm going to switch colors here a little bit. Oh, we still have an e, so it's still exponential, and I still have a trig. On my list of LIATE, I still have a trig, I still have an exponential. So my u is negative sine of x, and my du is e to the x. So the derivative of u will be negative cosine of x, and the integral of du would be e to the x. So if I take this piece over here on the right and I fill it in, this would become uv, which is negative sine of x. And my v is, see, I have bad handwriting. I wrote u twice. Be very, very clear about your u's and your v's. Be very careful with those. So u v minus the integral of v du dx. Okay. The first piece is still cosine of x e to the x equals cosine x e to the x dx. Oh my goodness, what are you noticing? Well, I'm back at e to the x negative cosine of x again. I'm going in circles. And if I kept going like this, I'd wind up with this really long branching tree that would get huge. And I don't want to do that. But let's see if we can clean this up a little bit. Maybe something good will happen. That's my original problem. Cosine of x e to the x. I'm going to distribute this negative. So this is plus sine of x e to the x. Negative times a negative is a positive, but this negative here makes this whole thing negative. E to the x cosine of x dx. All right, I could keep going. And I could use integration by parts here again. But again, I'm just expanding this and it's getting larger and larger and larger, and that doesn't do anything for me. But look a little closer. I have e to the x cosine of x dx. On the left, I have e to the x cosine of x dx. Are those like terms? Yes. Yes, they are. So I'm going to add this piece on the right all the way over here to the left. This is the problem if we were in the classroom and take up the whole board. So this is 2 integral e to the x cosine of x dx is equal to cosine of x e to the x plus sine of x e to the x. I lost an x. Now, we don't want a 2 there, so I'm going to divide everything by 2. E to the x cosine of x dx, that's my original problem, is equal to 1/2. I'm going to factor out an e to the x cosine of x plus sine of x. All right, that, folks, is the answer. A little crazy, but that's the answer. Good job. One more trick for us here. This is the tic-tac-toe method, and it's only used when the algebraic term is present. So if I have p times f, p kind of meaning my polynomial, my algebraic term, f of x dx, what you can do is, so my tic-tac-toe method, where p of x is my polynomial. So what happens is you're going to make a table, or tabular method, p of x and f of x. And we are going to find whatever that p term is, and we're going to find derivatives. So we want derivatives or derive until 0. And if it's an algebraic term or a polynomial term, that's going to happen. And in your f of x terms, we integrate as many terms as necessary. And so what happens is you kind of match them on the diagonal. So this first one will match up with the second one. The second one matches up with the third one, and the third one matches up with the fourth one. And again, you'll hit 0 somewhere in here. And then we have to alternate the signs. So that part's a little bit weird. So the first one is positive, then negative, then positive. And so then you're going to match them up, positive, negative, positive, negative. So this one's actually easiest to see kind of in action here. So what we're going to do is, here's my algebraic term, here's my trig term. So P of X is my x squared minus x. And what we need to do is take the derivative all the way through. So I've got 2x minus 1, and then 2, and then the derivative of 2 is 0. Let's not underline this piece. Okay. And then for my f of x term, that's the other one. In this case, it's cosine. So now we have to integrate. So the integral of cosine is sine of x. The integral of sine of x is negative cosine of x, because remember the derivative of cosine is negative sine, and I want a positive. And then the integral of negative cosine is negative sine. So I know I'm done in the list on the right because I've matched up with the zeros. So now we have to match them up on the diagonal. So x squared minus x goes with sine, 2x minus 1 goes with negative cosine, and 2 goes with negative sine. And then don't forget about the sign. So this is positive, negative, positive, and they would alternate all the way through. So how do we put all this together? Well, they get multiplied. So this becomes x squared minus x times the sine of x minus 2x minus 1 times a negative cosine of x plus 2 times a negative sine of x. So I'm going to go through and clean up my signs a little bit here, the ones that are kind of random. So this becomes x squared minus x sine of x plus 2x minus 1 cosine of x minus 2 sine of x. And we just integrated, so it should go in the end, plus c. Now, it's very, very, very easy to mix up the pluses and the minuses there, so just be careful with that. You're going to have questions. We expect you to have questions. That's okay. Keep trying. The worst thing you can do is just shake your hands and give up at this point. You are more than halfway through that AB material. We actually just have 2 more ideas to cover on the AB topics. This is getting into BC stuff. This is hard. This is hard. Remember that once we hit January, we meet every other day. You want to say hi, Jacob?
I'm going to sit next to you.
Okay. All right. Good luck. Reach out to me with questions. Reach out to Mrs. Oakes with questions. Keep going at it, though. Keep going at it.